Today, on episode number 807 of CXOTalk, we're discussing the intersection of business strategy and technology with Carl Weiss. He's the Chief Technology Officer of Caterpillar.
We are the largest manufacturer of construction and mining equipment, off-highway diesel and gas engines, and a leader in gas turbines and electro diesel locomotives. We've got almost 110,000 people, and last year we had revenue of almost $60 billion. So yeah, a large company. We have over 4 million assets actively running around the world today, and 1.4 million of those are connected to us, connected to our customers and our dealers. And speaking of our dealers, we have global coverage, 156 dealers in almost 200 countries around the world.
That's incredible. So you have 110,000 employees, 109,000, and 1.4 million connected devices. You're CTO of this enormous landscape. How do you manage that? How do the pieces fit together?
My role as CTO is really twofold. One is to bring those folks together at a leadership level and coordinate and align our technology investment and platforming and ensuring we serve our customers consistently and get the most out of our research and development investment. And then secondly, I have some direct responsibilities that surround our software development team, all of our electronics, our autonomy and automation team, our hydraulic systems development team, and then the manufacturing locations around the world that make our advanced components like hydraulics, transmissions, drivetrain, operator cabs, etc.
As you look across this broad set of products and technologies, is there a common thread or a common base that you use?
If you asked our product development community in particular that question, I think by and large they will all answer, it starts with the customer. We are a very customer-led R&D organization, meaning we don't develop technology because we can or for the sake of showing we can, but using the latest technology to help our customers solve their greatest problems and become more successful using our equipment and solutions than with any of our competitors.
That's really interesting. When you talk about being customer-led, how does that feed into the business strategy? So in other words, you've got the technology piece, you have the business piece, and it seems like the glue maybe is the customer.
If we serve the customer better than anyone else, we will have good business outcomes. If we develop those technologies and solutions in a way that leverages our scale, then we will have good business outcomes. So I think using that customer as our North Star kind of solves all of those equations at once.
Can we jump into a discussion of some of your products? Because you build this large equipment, and I don't think people realize the extent of AI, machine learning, and autonomous operation that's involved.
It shocks people sometimes to realize how technologically advanced our organization and our equipment is. Just to give you an example, we have the largest fleet of autonomous mining vehicles in the world, and have been doing that we've been developing it for a couple of decades, but have been in a production environment for over 10 years in mining around the world. And today, that fleet of almost 600 trucks travel the equivalent of more than 3 times around the Earth every day without an operator in the truck. So it's pretty amazing technology.
What's the evolution or the history of that kind of technology at Caterpillar?
We started this journey with the DARPA challenge a couple of decades ago almost, and really leveraged university talent and our own talent to develop a driverless truck. Maybe making the truck a robot was the easy part. The hard part is then making it productive and having a fleet work together autonomously in an operating environment that has, dust and obstructions and obstacles. And so over time, when we began this journey and first put our trucks in a mine site, we had more than 200 stoppages every day because of different reasons, just to make sure everything was safe. And over time, we gather a lot of information through our LiDAR and through cameras and different ways of sensing the environment. And we've been able to use machine learning to really teach our algorithms over time how to adjust to the environment, what to be concerned about, what not to be concerned about, how to approach different obstacles in different ways. And through that, I think over 230 million kilometers of travel, we have had zero injuries. So we've been very proud of that.
The safety aspect, maybe weave that into it, because unlike many products, in your case, if there is a product failure, it can literally lead to death or severe injury.
Our largest mining truck carries over 400 tons of material. So it's a very large vehicle, and safety is one of the reasons that our customers have moved toward autonomous vehicles in their mine sites. We have seen, and our customers have told us, that their injury frequency, their severity of injuries have declined in all the cases where we have implemented autonomous vehicles. And so we are proud of that and continue to offer our customers even more improvements in that space to ensure that continues.
Why is that? What is it about the autonomous vehicles that have such an impact on safety?
A lot of our mine sites are 24-hour operations, and that takes its toll on human operators. One of our first safety devices was the ability to alert the driver and their management of fatigue when drivers would fall asleep. And so that all by itself has been an improvement in first helping them understand fatigue and how to avoid it and to alert people when they are fatigued. But that has moved to the ability to then take the operator out of that equation and not have that risk. There are other risks, of course, in the mine site. That's just one good example. But our vehicles are able to just consistently continue the operation they've been asked to do without distraction or fatigue. And I think that's made a large difference.
Please subscribe to our newsletter, subscribe to our YouTube channel, check out CXOTalk.com. We really have great shows coming up. We have a very technology-focused audience. Can you give us a sense of the core technologies that make autonomous vehicles at Caterpillar possible?
LiDAR has been a key technology for us from the beginning, and the ability to look far enough in the distance and through a lot of different environmental distractions has been critical. The ability to capture millions of points per minute has given us the ability to have confidence of avoiding obstacles and staying on course. as we've evolved, we're using more and more camera technology and and radar technology for different purposes to also watch different parts of the vehicle so that we can avoid other safety incidents that may not be straight ahead, but beside the vehicle or in back. But all of this is dependent on connectivity to GNSS satellites and knowing where we are. And as we evolve, we are working toward a more local based knowledge of the vehicle, at what's around it, so that we can improve our capabilities even when we lose line of sight to a satellite, as an example. So it's been a journey, and we continue to improve upon that.
That's really fascinating. Millions of points of data per minute.
Yes.
It's an extraordinary amount of data, and I assume gets to the earlier point that you made right at the start, that you have 1.4 million connected devices out there.
It's a scalable strategy when we talk about connected assets, from connecting a very small piece of equipment for a lawn and garden care provider to this mining truck that is operating in an autonomous environment. The amount of data per minute or per hour or per day is very different. And so we're able to serve both ends of that spectrum with various levels of data. And for instance, in our mass amount of product, we are operating really in a cloud native environment of where to store and process our data, to this mine site where this massive amount of data has to be real time for obvious reasons around safety and performance, that those are on premises data storage. And so we have a great team that does a excellent job of looking at the different needs of our customers along that spectrum.
The whole strategy of data and analytics seems to have transformed the nature of Caterpillar's business.
For sure. We began our telematics journey really in the 1990s, but it was more of a niche part of our business where we engineers were working on how to get better, faster access to information when we test in the field. And as capabilities have improved and the ability to send and receive data in mass amounts at a reasonable price, and the computing capability to scan all of that data and make it useful, has transformed how we treat our data, and how we have now standardized on putting telematics on all of our equipment as it leaves the factory, so that we're able to help our customers be safer and more productive and save money all at the same time.
In a way, there are, correct me if I'm wrong, two broad parts to your technology. One is the underlying machine, the physical machine that you're building, including the engines and all of those physical components. And then you have the data analytics, telemetry part of the company that involves machine learning. So these are very, very separate kinds of technology tracks.
Yes and no. They come together in many ways because, for instance, the transmission has several sensors in it, and we have the ability to take the data that we've collected over that 1.4 million assets and scan the data for anomalies, and to then be able to more proactively let our customer know that a problem may be occurring, whether it's an operator operating in an unsafe way, or whether it's a clutch that's going to wear out, or in an engine when the oil gets diluted to the point that it needs to be changed. We're able to catch those and speed up the information to our customer to save them downtime and a costly repair. So they kind of come together in how we're treating the data.
What about from a machine learning perspective? Where does that come into play? And I'm asking because that's what everybody is interested right now. So many organizations are looking at AI and looking at machine learning to figure out how to improve, whether it's their internal operations or improve their products. And it seems like this is a core part of your innovation.
It certainly is. Maybe I'll give you a couple of examples to give a flavor for it. In our autonomous and automated operations, we're able to gather that information that's coming in at a very rapid rate, at a massive amount of data, and teach the algorithm over time to reduce the number of stoppages on in the operation, so that over time that system becomes more robust. And that learning is just an ongoing process, and it makes us better and better over time. And another area I would talk about is many customers ask our dealers and ourselves to help them manage their fleet in looking at a large fleet of equipment, looking for those anomalies. And we have fleet managers that sit behind a screen looking at fleets of machines and looking for those anomalies, the fault codes and temperatures and different things. And we've been able to use machine learning to speed that process up, to make one fleet manager much more productive, and to provide much quicker feedback to the customers and dealers on where they should focus their time, because we're all short of talented people right now. And this just enables our teams collectively to be more productive and to save our customers time and money.
What about the data architecture that you've put into place to handle this level of scale?
We are managing that data in largely, and I mentioned the on-prem data a little bit different than the rest of the 1.4 million connected assets. But for the large amount of equipment around the world, we have a cloud native environment where the gateway that connects to our equipment, the data processing, and the storage all happens in the cloud. And having that cloud native environment, kind of serverless environment for us, really allows us to maximize the use of our investment and really minimize the overhead costs long term for us, and it allows us to keep up with the latest and greatest speeds and storage capacities that the industry has to offer.
What about electric vehicles?
We have very small equipment that is used lighter duty applications a few times a day in urban environments, to the very large mining equipment that we talked about earlier. Both ends of our equipment line are, and I would put data center support in that large end of things. Both ends are moving fairly rapidly toward electrification. The small end, because we can leverage automotive scale, and they're in environments that allow for longer operating times on battery. And to the very large end, because our mining customers and our data center customers are very focused on sustainability, and they want to be able to, let's say in a mine site, operate with a lower um, uh, uh, impact on the environment, and they've made commitments publicly about getting their mine sites to that level. And so we're last fall, actually in 2022, we introduced our 240-ton payload truck that was fully electric drive, operated from a battery. We demonstrated it at our Tucson proving grounds and showed that we're able to make a full load production in trip and operate as well as our diesel equipment in that environment. But we, in the middle of that equipment line, that will take longer, for reasons of access to the grid, for reasons of the ability to run all day with a charge. And in a lot of locations around the world, they're asking us to really look at alternative fuels that will lower their impact on the environment while enabling them to be mobile and be productive without a grid nearby. So we've got a lot going on in this space.
So this push for electric vehicles, is that being driven primarily by sustainability or vehicle performance, or what? What are the underlying drivers for that?
It's really a customer-driven need, and we take the lead from our customers on what they need to be successful. I think in the very small end of our equipment range, we have customers in environments that are really going to necessitate the need for electric vehicles, and they are genuinely interested in reducing their environmental impact and want us to provide them the best option that we can to do that. And then on the far end, on the mining side, we're there directly supporting our mining customers in their commitment to getting to a carbon neutral position at some point in the future, depending on the customer. So we're very actively engaged with them, developing that mining equipment to do that.
So your customers are, for a variety of reasons, requesting electric vehicles, and so that pushes you to develop the R&D that's needed to accomplish that.
That's right. We've made commitments ourselves relative to sustainability, and for instance, for every new or improved product that we have in our portfolio, we've committed that all of those that will be introduced between now and 2030 will continuously improve on reducing environmental impact that they have on the ecosystem as we do our product development. So it's really both driven by our customer and our own commitments to sustainability.
We have a couple of questions from Twitter, so why don't we jump to those? And our first question is from Chris Peterson, who's asking a moonshot question. Well, literally a moonshot question. He's saying, is Caterpillar planning to play a role in autonomous or remotely operated machines for possible use on the moon or Mars in the future, because bases will need excavating?
I've been lucky enough to spend time with NASA in the last few years, because we actually have sponsored a Lunabotics competition with NASA over the last several years. And I've been to the Kennedy Space Center, been to their labs where they replicate as best we can the regolith, the moon soil, and our competition has been for university teams to develop a small machine that will remote control or autonomously operate in that regolith and be able to drill down through the regolith to extract rock, because that's a very real application that NASA is interested in. And we've been working with them and helping them on that journey.
We have another really interesting question from Twitter, and this is a completely different subject from Elizabeth Shaw, who says, what kind of innovation, either product innovation or business model innovation, is part of your set of responsibilities or your remit at Caterpillar?
My team is responsible for what we call the new technology implementation process and the new product implementation process. And so we're constantly working to lean those processes out within Caterpillar, and we set the process and the guidelines and standards for the company on how they run those product development programs. And so in that way, we're consistently working to make improvements on our business processes. And we spend almost $2 billion a year in R&D, and so that's a very big deal for us. Relative to innovation on product, we're really at the heart of the main componentry of Caterpillar. My direct team does all the software development, so we are working to speed up that process and take errors out of that process. One of the most important parts of our product development time is testing. And when I was a young engineer, we always we built a prototype, we tested it, then we built a pilot machine to run down the manufacturing line, and then ran it in operator sites. Today, we still do some of that, but a large part of what we do, we use what I'll call digital twins of components that we build in the software environment and run tests, whether it's finite element analysis on structures, whether it's cooling analysis on our cooling system, or whether it's performance and thermal analysis on transmissions. But we do much of that now in a computer environment, which speeds up the time it takes us to develop a product. And we're able to run our systems through hardware in the loop and software in the loop to test out our software and to do it in time much faster than real time in many cases. So we're kind of at the heart of a lot of those improvements to our business.
That's interesting. So digital twins are really, it sounds, integral to your technology and product development.
Definitely. More and more integral.
What about the relationship between business strategy and technology strategy? You are Chief Technology Officer, which of course implies the technology aspect, but where do you intersect the ultimate business planning and strategy for the company?
Every year, we organize a group of senior technologists. We call it the Senior Technology Leadership Forum. And they're chief engineers and leaders across our different business units. And they come together and they debate and vote with their money on where we invest our future dollars, our collective research dollars. And then they make a recommendation that and bring it to our product development council, which I chair and includes my peers across the many business units to really fund those collective investments, which really leverages the scale of Caterpillar and also drives consistency in the technologies that our customers eventually see in the marketplace. The other way is I talked about our new product development process, NPI process, and we have set up the the framework that enables us to measure all of those product development projects and how much investment is approved, and making sure that those development programs meet the goals, whether it's performance, quality, cost, and timing, to ensure that we're getting the most out of our R&D investments.
What are the key performance indicators, the KPIs or metrics that you use for evaluating things like R&D investment?
We do compare programs of similar nature to each other and are continuously looking for ways to be more efficient. But really, it comes down to performance, quality, cost, and timeline, and ensuring that there is alignment before the program starts between the technologists, the program managers, and upper management on what the goals are, how much will it cost, the timeline, and the expected return. And then we track those over several years.
How do you drive that alignment? Because somehow I'm sure it's not simply, oh, let's, have a cup of coffee and we'll figure this out and then we'll go on our way.
There are many tough discussions and meetings along the way, and I'm very proud of the fact that we have a deep bench strength of experts that have done this a few times and are able to really collaborate for what we think's the best for our customer and for the enterprise. But that doesn't mean we always agree. And it takes us a while at times to get to that, I'll call it consensus. It's not always, but yeah, we aim to get to a consensus on those big investments for sure.
So aligning, as you just said, what is best for the customer along with what works for Caterpillar. And then I'm sure another layer on that is what is practical and feasible from a technology point of view within whatever the reasonable time frame is.
Exactly. There is always more that we would like to do than we can afford or have time for or resources for. We have a lot of customer requests and expectations, and our teams always want to meet those as fast and as best as they can. But we can't do everything for everyone. And so the key part of all that is really prioritizing, right? And saying, where will we make the most impact for our customers, and where does Caterpillar have the advantages that we can leverage so that we're serving them best?
We have another question, again from Chris Peterson, another thought-provoking question, totally unexpected from me, as unexpected as the moonshot question, which is, do the digital twins and software simulations roll forward into AR and virtual reality tools for teaching and doing maintenance and operations?
It's a journey, as we have a team focused on AR and VR because it's becoming more and more important to our ecosystem and gives us capabilities of doing things we couldn't do before. As an example, it's very important for us as we develop a new product that it is repairable, that it's easy to do maintenance on it, and that it's safe for our dealers and customers to work on that equipment. So it used to be, when I was young, that we built those products and for the first time had our own mechanics work on it and give us that feedback, and we would do a safety audit. And then after you built the first one, you had to go back and make the changes needed. Whereas now, using a virtual reality environment, we're able to do most of that really virtually with those mechanics now, where they can put the VR headset on, they can try to get inside the equipment virtually and reach, and we can do A high percentage of our safety audits that way. So that's just one example of how we're using that technology.
So that technology is actually in practical use today, AR and VR?
Yes. In fact, we used to have what we call a cave that we've probably had for almost 20 years that was very much a projection of the equipment around you, whereas now with the VR technology, we're able to put the headset on and live that environment without being in a actual cave.
You mentioned safety earlier. Given the huge importance of safety, how do you think about that and manage that? And again, I'm sorry, very, very quickly though.
Safety is huge importance to us, and Caterpillar has consistently improved our reportable injury frequency to world-class levels. Today, we're very focused on ensuring that the severity of any injury is minimized and eliminated. And so we're focused on making sure folks in our own organization are outside of any line of fire or risk. And we're looking at the same things for our customers that operate and maintain our equipment.
How does technology and innovation strategy get addressed in the system architecture?
We want the system, especially the electronics and information system, to be upgradable very rapidly. So we are developing architecture, software architecture that's agnostic to what display you use, how you use it, and we're able to use more of a central domain computer that has a partitioned architecture to allow that modularity and upgradability. I mean, for a short answer, that's where I'll leave it.
So the modularity is independent of the specific product because you have underlying components that I'm assuming are then adapted to bigger, right, smaller.
Exactly. More plug and play capability.
International, you're in a very broad set of markets, and you've even spoken about excavations on the moon. So how do you adapt your technology strategies to meet these very diverse geographies?
It's really important for us to do what you just said. And I would say there are three things we do to make that possible. One is we really pay attention working with our dealers on what the local customers need because they're different and they have different economics in some cases. Second, we work to hire the best talent in region because they know that environment, they know the customers, they've lived it. And if we get the best talent there, we know we will develop the best products for that region. And then third, we work closely with governmental and non-governmental agencies to make sure we have common sense standards and laws in those areas that both support the customer and our business.
What about your global supply chain? How do you ensure supply chain resilience given the size, the diversity of your products and so forth?
We have, like most companies, worked on a just-in-time lean supply chain, and that's bitten us in the last few years with the pandemic, the supply chain disruptions. One of the things that have been really helpful to us is that we tend to build products in region for the region. We don't always do that depending on the volume, but that's how we've set up our manufacturing and supply network. So that has served us well. However, we have paid more attention more recently in ensuring we have more resiliency, maybe more multiple sources rather than single sourcing certain components. And of course, microchips was a big part of our supply constraint in the past upturn with the pandemic as well. And so we've taken steps through sourcing and inventory buffering and working with our tier 1, tier 2, and tier 3 suppliers to improve that.
What technologies are you excited about, and where is the set of technologies that you're working with headed right now?
I've been an engineer and at Caterpillar for 35 years, and this is definitely the most exciting time of my career relative to what's possible. And what's really important is the combination of some of these technologies. We've talked about generally all of the key ones, but we call it ACE technologies: autonomy, alternative fuels, connectivity, and electrification. And how we bring those together, which we talked about in most of this hour, is whoever does that best and makes it easiest for our customer will win and will help them be successful.
And with that, it seems like a good place to end. We're out of time. I want to say a huge thank you to Carl Weiss, the Chief Technology Officer of Caterpillar. Carl, thank you so much for taking your time to be with us today. I really, really appreciate it.
Thank you, Michael. It was a very engaging conversation.
And thank you to everybody who watched, especially to those folks who asked all those great questions. Now, before you go, please subscribe to our newsletter. Subscribe to our YouTube channel. Check out CXOTalk.com. We really have great shows coming up, and we will see you next time. Have a great day, everybody.